Hey guys, welcome back to the channel. So today we are going to start a new series in which we will take up important and most commonly asked interview questions. Our goal is to not just understand and solve these problems, but instead discuss everything which can potentially pop up during an interview setting, so that you can conquer that particular question and your complete interview with flying colors. Before we jump onto the today's problem, if you are a first time visitor and you are interested in the content which DevGuides features, please do subscribe to the channel and also don't forget to press the bell icon so that you don't miss any notifications. The first problem which we will take up today is this very famous and classic problem which is called Anagrams Problem. So for those who don't know what an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Let's take few examples to understand that. So listen and silent. These two words are anagrams because I can rearrange the letters in the word listen to get silent. Hence they are anagrams. In the same way, binary, braining, these two are anagrams. Dormitory, dirty room. The eyes, they see. All these are examples of anagrams. Let's now see some examples which are not anagrams so that we can make the differentiation between these two. So ban, banana. These two are not anagrams because I can never rearrange the letters in the word ban to get banana. So they are not anagrams. Same way, ABC, ABB. Stress, dress. Man, name. These are examples which are not anagrams of each other. So now that we understand what an anagram is, let's try to see how an interviewer is going to ask you a question or put forward a question in front of you. He obviously is not going to ask you what an anagram is, but instead you will be asked something to code, to program, to solve, right? So let's see the problem statement. And the most commonly asked question is, given two strings, determine whether they are anagrams. So basically, interviewer is asking you to write a function or a method which will accept two strings, and then your method has to derive whether or not these two strings are anagrams or not. Let's take some examples. So if you see, this method accepts two strings which is silent and listen, and your method should return true because these two are anagrams of each other. This other one accepts ABC and CDE as the input strings, and then in this case your method should return false because of course these two are not anagrams. Now let's see how we can solve this problem. But before that, let's see what are the possible follow-up questions which you can ask the interviewer. This is indeed very important step because it will help you to understand the problem in a better way, and in addition to that, it will leave a decent impression on the interviewer because basically what you are doing is you are clarifying all your doubts before trying your hand at the solution. So one of the questions which you can ask is, should our solution consider case sensitivity? Which basically means, do we have to make differentiation between uppercase character and lowercase character? In our case, let's ignore the differences in the case. So one more question which you can ask is, do the strings just consist of letters or can they have other characters in them? By other characters we mean special characters like ampersand or white space or punctuation, like that. So let's limit ourselves only to the letters, and in case the input string consists of any special characters, we will ignore them. So the other question which you can ask is, are the strings necessarily the same length? Which means that the two input strings which you will receive as an argument to your function, will those two strings will be of same length or they can be of different length? In our case, let's keep it as no, which means that the two strings can be of different length. So one more question which you can ask is a string an anagram of itself? which means that, for example, the two strings which are passed to the function both are same. So whether or not your function should return true, which means that those two are anagrams, or it should return false. So this final and the most important question which you should definitely ask your interviewer is, are all the letters from the English alphabet? Why this is very important? Because internationalization is very important for all the companies. So when you ask such a question, it will give very nice impression on the interviewer that you are thinking on those terms. You don't want your algorithm to limit for a certain character set, but you want to widen your horizon and cover as many characters as possible. Most of the interviewers will ask you to implement your algorithm only for the English alphabet, and that's what we will be doing in our example. Now let's see how we can solve this problem of anagram. And of course there are multiple solutions, multiple approaches which you can use to solve this, and here we will discuss two of them. So the first approach is sorting, and in this approach what we do is we first sort both the input strings and then compare with each other. Let's see an example to understand that. Let's say we have two strings, binary and brainy. So what we will do is we will sort binary and then we will sort brainy, and then we will compare these two resulting strings with each other, and if the two strings are equal, it means they are anagrams, and if they are not, it means that they are not anagrams. Okay, so let's see some code now. So I have this method is anagram using sort, and this method accepts two input strings s1 and s2. Okay, and then the first step which we do is we are cleaning these two strings, and what clean string method does, it basically replaces all the special characters from both strings with empty string and then converts the resulting string to lowercase. So basically what we are doing is we are ignoring the case, that is 0.1, and then we are also ignoring all the special characters within the strings. Okay, so coming back here, after cleaning the string, we want to compare the length of these two strings, because if s1 and s2 are of different length, then of course they cannot be anagrams, so we can return false from here straight away. In case they are of equal length, then we can proceed further to convert these two strings to character array so that we can sort them. So we use arrays.sort method to sort this s1 array and s2 array. And then finally, once we have these sorted arrays, we will compare these two using arrays.equals method. So if this method returns equal as true, that means that these two strings are anagrams, and if it is false, then they are not. Okay. So now let's take a look at the efficiency of our algorithm, and for that we will check its time complexity. So time complexity, if you don't know, it describes the amount of time it takes to run an algorithm, and it is most accepted criteria to measure the performance of an algo. So if we look at our solution, this solution involves sorting input strings before comparing them. And any sorting algorithm like merge sort or quick sort, it runs in time order of L log n. So the time complexity of this solution is logarithmic, which is order of L log n. This solution is pretty good and simple with decent time complexity, but can we do better? Okay, so now let's take a look at our second approach, which is called histogramming. In case you don't know, a histogram is a graphical display of data using bars of different heights. Okay, so in our solution, what we will do is we will make frequency histogram of characters in both input strings. So what that means is we want to count number of occurrences of each character, and if we visualize that in histogram, each unique character in the input string will have its own bar, and bar height will define the occurrence count of that character. Okay, so we need a data structure to store this character occurrence count information, and we can use different data structures like arrays or hash maps to build histograms. but in our case we will make use of hash maps. So let's see an example to understand this solution. Okay, so let's say we have these two strings, stressed and deserts, and we want to find out whether or not these two are anagrams. So in this approach of histogramming, what we want to do is we want to build frequency histogram for these two strings. And how do we build that? So what we will do is we will loop through these two input strings, okay? And while we are looping through it, we will store the character and its occurrence count in a data structure. And for our purposes, we are going to use map as the data structure. So map, if you know, stores the data in key value pairs. So what we will do is we will store a character as the key and its occurrence count as the value in the map. So by the time we finish looping through the strings, we will have all unique characters as the key in the map and their occurrence count as the value. Okay, so let's see an animation to understand what I am talking about. So we have finished looping through stressed, and if you see the map, we have all the unique characters in the stressed as the key and their occurrence count as the value in the map. Okay, so now what we can do is we can create similar frequency histogram for deserts, and then we can compare these two histograms to find out whether or not the character and their counts are same in both the maps. And if they are same, these two strings are anagrams, otherwise not. But instead of using another map to store the data for deserts, what we will do is we will destructively modify this existing map while we are looping through deserts. So for example, when we loop through deserts, if we get D, we will reduce the count of D in our existing map by 1. Same way, when we get E, we will reduce the count of E in our existing map by 1. So by the time we finish looping through deserts, if we have all the count for all the characters in the map as 0, that means that these two strings are anagrams. And otherwise, if we have any character which have its value greater than 0, then these two strings are not anagrams. So let's loop through deserts and see how this map gets updated. So now if you look at the map, all the character counts is 0, and that means these two strings are anagrams of each other. Okay, and in case we had any character which had its count greater than 0, then the result will be false, which means that the two strings are not anagrams. I hope the solution is clear to you guys. So now let's jump on to Eclipse to see the actual code. Okay, so here I have this method isAnagram using map histogram, and it accepts two strings s1 and s2. Okay, so the first step which we do is clean the string, and clean string basically does remove all the special characters from that string and then converts that string to lowercase. So once we have clean strings, then we do length validation. So if these two strings are not equal to each other in length, then we straight away return false because they cannot be anagrams. And if in case they are of equal length, then we proceed further to create the character arrays for both the strings. Once we have character arrays, then we build frequency histogram for the first string s1. Okay, so here we are building the frequency histogram for s1, and then we destructively modify histogram for s2. And as we already saw in our example, by the end of this, if map contains all the character values as 0, then these two strings are anagrams, otherwise we return false. So now let's take a look at the efficiency of this algorithm. If you look at the code, we have two major operations in this algorithm. First we loop through string 1 and string 2, and then we loop through map, which is our histogram. So looping through first string takes order of m, and looping through second string takes order of n, and finally looping through map takes order of o. So when we combine all this in terms of time complexity, it would be order of n. So this algorithm takes linear time, order of n, and it is definitely an improvement over our first sorting solution, which took logarithmic time to run. Okay, so now that we have seen both the solutions, let's try to compare and see which one is better solution. Our first solution involved sorting, and it took logarithmic time, which is order of n log n, whereas our second solution of histogramming took linear time, which is order of n. So this way our second solution definitely ranks over first one because of its better time complexity. But one point to note is, we have used default Java sorting in our first solution, and it is basically merge and quick sort, which takes order of n log n. But if we can sort the data in a way that it takes linear time, then our both solutions will be equally good, right, in terms of time complexity. And indeed there are some sorting algorithms like count sort which takes linear time. So before we wrap up this video, I would like to tell you a few more questions on anagrams which you can possibly face in an interview, because the problem which we solved today is just one problem on anagrams, and there are quite a few more which are popular and gets commonly asked at the interviews. So one of them is, given an array of strings, return all group of strings that are anagrams. So basically you will be given an array which contains many strings, and then you have to tell that which string is anagram of which other strings. You have to group those strings and return. So another question which you may get asked is, find all anagrams in a string. So basically in this you will be given an input string, and then you have to find all substrings which are anagrams. So one more pretty common question which gets asked is, given two strings, how many characters do we need to remove from either to make them anagrams? So basically you are given two strings, string s and string s1, and then you have to remove certain characters from both the strings until they become anagrams of each other. So these were the few common questions which gets asked in an interview often. So you can try these questions on your own, and if you have any trouble solving them, then you can leave me a comment and we will solve them together. Okay, so that's all in this video guys. I hope you liked it, and if you did, please give it a thumbs up and do share it with your friends. Please do subscribe if you wish to understand and solve similar problems in future. See you next time.